so well. Maybe you can double check if the online audience can hear us. So thanks a lot for all the people who are connected to us live via video streaming right now. So Ambrosus has a huge community worldwide, and we're trying to make sure that all our community members worldwide can have access to the latest developments on the project and follow us as we move around the world, presenting our exciting stuff. So I'm just going to start, just for the benefit of my own presentation, how many of you know about Ambrosus and know what it does and so on? It's about half, slightly more than half of you actually. So beyond just the basics, kind of beyond just what's on the website, maybe like that it's better, because I know there are some core community members, but most of you are still fairly new, right, to Ambrosus? So I'm just going to go have a basic overview about what we do. And then, so you've seen the program on the Meetup, so I'm just a recap. So I'm going to start with a general intro to Ambrosus. Then we're going to have Vlad, our Chief Product Officer, is going to run some demos and going to show you AMB-NET and the key dApps that we've built on it. And then we will have our developers of Ambrosus, the dev team, speaking about their specific topics that they're focusing on, giving a talk about the key issues in scaling blockchain or solving the major problems of IoT. And finally, we're going to have a mini panel where we can take questions from the audience to discuss the technical developments in the sector, as well as take the questions from the online community. And then in the end, there'll be pizza and snacks, drinks, t-shirts, and good mood for everybody. So let me just go ahead and start with Ambrosus' presentation. So we are focused on having the trusted quality of products. We want to create an opportunity for people all over the world to truly know what it is that they're buying, what it is that they're eating, or the medicine that they're consuming. So in a nutshell, Ambrosus consists of three fundamental parts. There is the blockchain part, which obviously assures the immutability of data. There is the smart contract powered data repository. What this means is that alongside the blockchain, we have a decentralized storage solution, and it can be powered by smart contracts to execute various transactions. And then finally, we have the whole IoT part. So we've built different protocols to enable sensors to talk to the blockchain. And when you combine all these three, you can enable sensors to talk to the blockchain. This is what we ultimately create, and all the other use cases are built on top of that. And what it does, it can literally allow you to have the repository of truth on the blockchain using real-world data. So you actually know the full history of the product throughout its life cycle. This is what we aim to achieve. The key aspects, so the core values of Ambrosus. So we have an open source ecosystem. Everybody can check it. Everybody can validate it. And it's focused on transparency. Information protection, so we work with corporates who do have an interest to keep their data private, but at the same time they do want to make sure that there is a public ledger assuring the integrity of this data. So we can provide hybrid solutions where they can selectively share the data with their consumers without having to go against their business interests. Because the main challenge the corporates have is they say, when the blockchain is fully public or sharing everything, we cannot really adopt it for our business. With that comes obviously the flexible architecture. So and later on, I'm going to demonstrate to you all the individual pieces that we've created. But essentially, we function as sort of a Lego for the corporates, so for the supply chain stakeholders, which means that they can pick up different details and they can build different solutions using the toolbox that we've created at Ambrosus. The solution is end-to-end. So we can provide the full value service from farm to fork in the case of food, or from the factory to consumption for any other kinds of products. We are focused on making everything developer friendly, so our devs have been hard at work making various SDKs and APIs to enable onboarding of different stakeholders as seamless as possible. And we've already released SDKs for iOS, Android, and JavaScript, which enables any developers with knowledge in those areas to create new solutions on AMB-NET. And not only can you create them, with the launch of the network now, you can monetize on them. So you can instantly have various business opportunities there, and you can monetize your solutions using the transactions and bundles generated on the network. And finally, the IoT space. So we have our own R&D lab in Switzerland that focuses on the hardware security element. So we are concerned both with the blockchain architecture as well as how do you make sensor to blockchain communications secure and scalable. I'm going to skip through the slide of benefits of blockchain since you're all part of the Ethereum community meetup. and go straight to the basic overview of AMB-NET. So AMB-NET is our core platform. As I mentioned, 3 fundamental parts: blockchain, distributed storage, and sensor protocols. So what it does, importantly, it's not software. So software comes on top of it. So we can integrate into various existing software solutions that corporates are using for their day-to-day management. And we also work with a variety of barcodes, QR codes, RFID. Quality determinants you have. You may have more. Is this one better? So people couldn't hear me? Okay, so is it better now? People can hear me? Okay. So let me know if the online community cannot hear us. So you can select, obviously, different parameters and program them to be tracked on the blockchain. So you select conditions. What is the temperature of delivery that you're interested in? What are the routes? Is the sound okay, or? Since the beginning, or? Hmm?
Sound is on, but like the presentation is definitely invisible.
So do I choose if people are blind or deaf, basically, which is not a nice choice. I mean, it's obviously it's got to be sound and video.
Yes, no, no better. Not, but now Maggie was not seen.
No, if I'm not seen, it's okay, as long as they can hear me.
Okay.
No, I mean, the presentation is more important than, my pretty face. So, can people see the slides? And they can hear me too?
Yes.
Okay, then let's leave it like this. So, what parts of the supply chain can we target? So basically, again, we are aiming to cover the entire supply chain. However, for different businesses in different industries or use cases, they might be interested in a particular part of the supply chain. For example, for some businesses, they're interested to actually track the product from the factory to the retail store. So traceability of raw materials is not relevant to them, but they want to know what happened to the medicine they distribute throughout the intermediaries. For some other use cases, it's the opposite. They want to see what the raw materials inputs have been and track those. So again, we can either develop, as I mentioned, take the approach of build it yourself. So basically, you select what parts you want to cover, or we can make the full supply chain coverage. And importantly, in the middle, so between all the tags and trackers and the protocols that send the signal to the AMB-NET, we have the cryptographic signature. So when sensors generate any readings, they're complemented by digital signature, which makes sure that the readings, the integrity of the data is assured at the sensor level. And this is a fundamental difference with Ambrosus compared to any other solutions out there, is that you don't transfer the data from sensors to some kind of a server, which in turn speaks to the blockchain, because you can hack the server, and then what's the point of even putting that data on the blockchain if you cannot trust it? Here, each sensor puts a cryptographic signature, so people can always verify the timestamp and the ID of the sensor that recorded it, improving the security of the overall solution. I'm going to skip through this slide because we have some other things to do. So in terms of the blockchain architecture, one thing that I will mention that is fairly relevant. So in our particular solution, we have created what we call bundles. So the core transactions on AMB-NET, on our blockchain platform, are not transactions in the traditional sense. Rather, they are called bundles. Each bundle consists of, this number is outdated, it's now 16,000. So 16,000 smaller transactions that can either be assets or events. An asset is a digital representation of a real-life object on the blockchain. So when you produce a pack of medicine, you can create a digital asset. And an event is any sensor-generated reading about that product. Location, time, humidity, pressure, light exposure, anything you want is a particular event. So we bundle 16,000 of those. We store that data on our distributed storage solution, so that data doesn't go to the blockchain. We only put the hash of the bundle on the blockchain, which permits us to scale. So ultimately what you have is that we have this pretty standard throughput of the blockchain of 50, 60 bundles per second, but each bundle is 16,000 transactions. And that makes the overall throughput of the blockchain around 800,000 transactions per second. So this permits us to work with corporate clients who want highly scalable solutions. As some examples of these solutions that we've built. So I'm going to run through only the dApps, because Vlad is going to show you the under the hood. I'm just going to show you the basic information about the products. We have to kind of black out the names here because it's a private company, but basically you might buy a beefsteak, and then you have a user interface. We have all the different stages of what happened to the product, and those are interactive. They show you the map, they show you the links to the relevant readings made by the sensors, and the producers can put any marketing information they want, or they can integrate it with loyalty points of supermarkets. So basically there's a bunch of stuff that companies can do to engage their consumers, which is fairly important for all the food companies who want to boost their sales or reinvent their brand. Similarly, I'm going to skip through this one. So other use cases we've had were in the commodities sector. So we ran a pilot project with one of the largest exporters of vanilla out of Madagascar. And again, vanilla is a highly precious agricultural commodity. It's highly precious because it's used in the perfume sector, so to produce perfume, as well as for obviously create the aroma for food products. Is still a problem, or?
Yeah, I mean, like now it shows the stats in the date.
Yeah, not great.
Sorry.
Is there an operator? It's slides are delayed by a fairly big amount of time. Yeah. So the video is, I guess, at least a minute behind the sounds. Or do you hear the sounds?
I'm not sure. I don't hear the sound.
But people say, do people complain?
No, people don't hear.
Well, maybe ask the community managers if the sound is fine, because they're supposed to have checked it. Anyway, so apologies for the technical things, but we're trying to make sure that the online community has high quality presentation and the sound is not disconnected from the video. So an important element, so it's a highly precious commodity, and there is also a lot of quality concerns, sustainability questions. So the companies, they want to source sustainably produced items, and they also want to make sure that they're getting value. So in the case of vanilla specifically, we measure humidity of vanilla. Why? Because it's sold by weight, and you're supposed to dry it really well before you sell it. And one of the most common ways to cheat is to sell wet vanilla and charge a lot more for the weight. So pretty basic use cases, but they cost millions or sometimes billions of dollars in losses. So we target those. Similar use cases in coffee about traceability. So for many producers, if they have certain sustainable practices on the farms, fair trade, ethical production, free from child labor, so there are a bunch of different quality variators which are not necessarily captured by sensors. So you don't have a sensor to confirm that the coffee has not used a child labor to be produced. However, what you do is you simply assure traceability. So if you have a farm that's certified by the UN or by Fair Trade Organization or any other body as a sustainable source, you simply make sure that the producer of coffee can show you that this coffee did indeed come from that particular sustainable farm. This is an example of an app. So on top of AMB-NET, obviously this one has sleek design and it was specifically developed for one particular company, but it shows you, importantly, how you can have the marketing and the business value for companies where they can tailor-made an experience based on their consumer preferences, have the unique information, have interactive map of the world where they show you the journey of the coffee beans from different countries finally arriving to your shop. And once again, it's kind of the same stuff that I showed you before, only in kind of quality design. So this is one of the examples of the dApps that people can build on top of AMB-NET and launch their startups on top of that. I'm gonna skip through these use cases because they're fairly similar. So importantly, for certain products, so this was an example of an airline industry. So in airlines, there is a concern about also how the food is stored through the distribution stages, and that they want to basically assure their customers that the food is good. So we've developed a solution where they could have, basically it would cost 3 cents per item to have 3 measurements of quality and origin of the product. So basically you can have pretty low cost solutions, and you can have highly scalable platform for tracking the food quality. I'm gonna skip through those. And so finally, in terms of the packaging, so here you have some example of frozen products, or so basically different kind of temperature use cases where changing temperature of the item can seriously damage the quality of the product. And what we do is basically we can also integrate with different kinds of hardware. So you can have an isolated box, for instance, and there is a simple sensor that simply sends the signal to the blockchain every time the box is opened. So you don't have to come with kind of science fiction use cases, but it's pretty simple. You open the box, the signal is sent to the blockchain, so therefore you can say maybe the item has been replaced and so on. So this allows us to approach this in a practical sense. So there are some companies who make kind of castles in the sky in terms of what they propose at the blockchain plus IoT, but here it's pretty simple and straightforward. And now Vlad will actually come and present the actual technical demo, so you will see how this all works under the hood. So you've seen kind of the consumer-facing side, the user-facing side, but now you will see how it actually works under the hood. So Vlad, our Chief Product Officer, Dr. Vlad Trifa.
Hi everyone. It's okay. Thank you. And here we go. Good evening. Hope you're doing well. Thanks a lot for your time. So I'll quickly do show a few slides. Just describe. Is that microphone actually connected, or it's for the recording? Ah, okay. So it's not for the room. Hello, hello. Okay, good. So I would just re-summarize a few key technical points from Ambrosus from a technology perspective. The first one is how we're structured. So if you look at most blockchain projects, how we compare to other blockchain projects, that's the first layer, and it's just where some proof data or some cryptocurrency element are implemented. In our case, we build a lot of additional toolings that makes a lot easier to access and develop apps and dApps on top of the blockchain. For example, and that's something what I'm gonna show in a few minutes. So first of all, it's APIs. How do you manage data? How do you store private data? How do you exchange data with other people that you trust? And I think one of the key concerns we have when we talk to those corporates is that many of them say, oh, blockchain is great, but I want my own private blockchain, which is already not a good start. Maybe they just need a better database, or they start understanding that the whole point is sharing that information. But then the next concern is like, I want to have a proof. I want to prove to my customers or partners that I'm a trusted company, but I don't want the entire data to be public, which is a second issue. And that's something we also built in our solution, where you can store private data locally, put a proof of that data online, and then be able to prove that in a later stage that, hey, the data I recorded hasn't been modified. So the data you're seeing is essentially the one we recorded. So on top of Ambrosus blockchain, we have AMB-NET, which is the set of tools and APIs to make it a lot easier to develop that. Of course, we build our API in such a way that it's very easy to integrate data from sensors and IoT. And finally, the last layer is different applications, custom applications and dApps that any company, any developer can come. It's very, very quick to start building applications, and I will show a demo of that in a few seconds. And that was really the whole point. So what I'll do is just jump a little bit more in the details what that exactly means. Is at the center, we do have our own blockchain. It's compatible with Ethereum. And this is our POA network, right? So that's the core blockchain element. Until there, it's similar. And of course, we're developing and improving our own core technology. But a really interesting aspect we've developed is those dots around, which are what we call gateways, Hermes nodes. And that's something the guys here, our team in Warsaw, has spent a lot of time developing, improving. We have released the code of that 2 months ago in open source, so anyone can go check it out, start playing, and I'll show a demo how that works. And the whole point of those gateways is that we have all those SDKs for web, for Android, for iOS, or sensors. It's very easy for those devices to send data through REST APIs. Of course, you need to trust the device and the signing. For example, if I take this example, here you have a sensor. That sensor will measure some data. That data will be signed locally by the private key on the sensor and sent over Bluetooth over the web. And the whole point is that because the data is actually signed on the device, it's like a hardware wallet. Even if someone here wants to change that data, they won't be able to because they don't have the private key. So this is how we allow some centralization to get a lot more performance and usability without sacrificing the security element. Now, if we look in more detail how AMB-NET is structured, is we have two data elements. First, we have assets. And an asset is any physical or logical entity in a supply chain or any other scenario that needs to have a unique digital identity. It's globally unique. And you want to identify, of course, and you want to prove existence or information about that asset at a later stage. It can be a container. So, for example, a container would be an asset, and then you track the history of that container over time. And that container, for example, could be linked to a purchase order, which is a legal document that says what you have to ship from where, when, and that contains various boxes, pallets, cases, or unique units. And you can link all of those things together. Every single one of those elements will have a unique identity, a unique ID that is global, globally unique, and that you can start using in an application. I think when I'll do a demo, it will become a lot clearer. The second type of data element we have in our model is assets. And as I said, objects, we have those physical things. It can be a batch of strawberries, a box of strawberry. Each one of those corresponds to an asset. An asset is like a placeholder, or maybe a folder which has a unique ID. When you create the asset, of course, it's empty. There's no data. It's just a unique ID that you can put on a physical product. But then you would start creating events around that. And an event is any piece of information, any piece of information that you want to record about an asset that you want to prove after the asset has been created. For example, that a box has been packaged or tested, or it has been shipped, clean. Whatever it is, you want to record that information in an essentially permanent and untamperable with way. I don't know if you can say that. So if I give you a very concrete example, you'd have here an asset, which is a pallet. That asset will be scanned by another asset. That other asset is a handheld scanner. It can have a private key on top in it, just like a hardware wallet does. It scanned the information that a pallet was seen with maybe additional information, and that scanner will send that data as an asset to AMB-NET. So, just one one or two more things about our API. So the whole point and the whole objective of AMB-NET, providing this higher level, was to enable developers, companies, partners to build new dApps, mobile dApps, apps in general in minutes without having to understand everything around the blockchain underneath. So of course there is blockchain, of course you can start leveraging smart contracts and such, but you can also just write a few lines of code and you already create digital identities of products on the blockchain without having to install a client and start writing smart contracts on top. The API of this is of course REST using JSON. It's very expressive, so we can model all sorts of data, events, anything that happens in the physical world. It's based on a lot of research at key institutions over the last decade. Easily, it's compatible with GS1, which are the main standards in logistics, and we really focus on developer productivity. And that's why we also have SDKs for Android, for iOS web, to make it super easy to build new apps. And I'll show you some example now. So the first thing is, when you create an asset, I don't know if everyone sees, but that's pretty straightforward. You just send a post request to one of those Hermes nodes, assets. You can either pass your private key or sign the message. It's not great to pass your private key in a REST request, but you can do for testing, but you shouldn't do it. But you can, but you shouldn't. So now the thing you send here content, the only content you have in an asset is the timestamp when you have created that asset, and you put your own public address here. So you want to say that, yeah, I have created this asset at this time, and that will be recorded. Then the second thing you do is just create events around that. So I would suggest we just jump to demos right away because it's always more fun. So I'll just take Postman, our good friend here. So I will essentially, it's exactly what I've shown you before. So I will create a new asset. I just send this send request. I'll have a 201 created. And what I see in the response is this was created by me. That's my public key. That's the timestamp when I've created it, which is theoretically now. I have a signature. So the signature is essentially this data here that is signed with my private key, so I can really prove that I have created that and no one else did. And here I have an asset ID. So the asset ID which I've just created is essentially globally unique, and anyone can start playing around with it. You know, you can just go here. Just 1 second. Here. And that's essentially what I've created here. Now, Angel explained before the notion of bundle. I can give you one slide afterwards how exactly bundle work, but this is essentially the bundle in which this asset was created, and that's the data I've shown you before. And that's that now you can start using, because as you've seen, it's just a URL. I didn't authenticate. You just type that in your browser, so it's an authenticated HTTP request to one of our nodes. You have the data from here, and now we can create events. So what I'll do is, let's create a small event here. Let's do it differently. So before I create an event, let me show you one of the things we've been working on in the last few weeks, is where it's work under construction. Please bear with us, but we've made a very, very simple dashboard that allows us to create events and play around. So this is essentially my account. I can see here there's a fresh asset that I've just created, that's 709, which was 2 minutes ago, and there's no data about it. Of course, it's not very, very interesting because there's no information. It's just a public placeholder. So let's add some data about that product. And what better than this, right? I wish they had the colder one. So let's take this beer, right? Lech. All right, so what I'm gonna do here is I just create this thing, you know, I have data, and I'm gonna say Lech beer. I just rewrote that in advance, of course. I put the URL of an image. I can put the size of the product. I can say it's non-GMO, it's kosher, whatever. I can put ingredients, good stuff. I'm sure. The brand is of course not ZVH, but it's Lech. And I'll just create that origin. And what's really interesting is I'm gonna take, for example, the barcode on that product, which is EAN, that's how it's called. It's 5900 something with 182. That looks decent, so I'm gonna send that. And what you see, of course, the asset ID here is the asset I've just created earlier. So I'm gonna send, I have 201 created, looks great. What happens now? Now, first, I go in the dashboard, and now I can see Lech beer, and there should be an image which is not there, which makes me very, very sad, which means they've put something to prevent people hijacking. There you are, but let's redo it even better. Lech beer, I take an image, and let's say that's the one. Let's take this one because it's fresher. I think we want to have an image of the beer. So open image, I take this URL, tag, tag. I think they're trying to be rude to me, so I'll just take it. Good. So, they don't want to. Anyway. So, I go back here, I just add a new nice URL thing, I resend. I'm updating the data, essentially. What happens is I go back to my dashboard, I'm gonna refresh. Now hopefully I still don't see an image, which is a lot of sadness. And I think there must be a cross-browser thing on their server because they don't want hot linking from other sites. So that must be the explanation. Anyway, what's really interesting here is that now you have all this information about the product. You have a QR code which has been generated, and that QR code essentially contains here you can see. So it contains essentially the unique ID of the product, which I've just created. Now what's interesting is you can also take a native application. Just give me 1 second. You can take a native application, which is just an iOS thing. So it's my big iPhone, so I just scan the QR code here, and you can see here, essentially it starts reading the data about this product. You can see, but I'll show you happily afterwards, and we can play around with the things. You can see all of that data is taken from the API. And what's interesting now is you take this asset ID. Again, you go here into our gateway, you type this asset ID, and you can see that's the initial information. And now I go check the events which I've created. And now I can see I've created technically 2 events. The first one with the wrong URL, the second one with the same image but still not working. And each one of those events has a unique event ID. Oh, yeah. Each one of those has a unique ID. And all that data, if you really want to make sure that it's really on the blockchain, because you're like, hey, that's just a website, that's just a server, how do I trust? Then what we build is very simply client, or just a very, very light client-only, front-end only client application. We'll put that in GitHub in a couple of days. But what this is doing is just, purely front-end, purely JavaScript. I'm gonna take that event. Come on. Wait. Okay. I'll take this event, for example. This is the event. I go here. And this is my event. And I can see in this application what it's doing is, first it's verifying, and you can download it, you can run it on your own client if you don't trust this website. It's on GitHub, but the whole point is this application is open source, you can download it, the source code is here. And what it's doing is it's taking the data from AMB-NET that you're seeing in an application, it's doing the verification, does the hash of that data on the blockchain match what I'm seeing from this API. So that means even if those guys, they made something bad and they want to change the data in their database, they can do, you will see automatically that it has been changed. It's verifying the signature. Was that data element really signed by this private key? You want to check if the event ID is valid. You know, is it essentially the hash of the content? You can check if the bundle itself is that valid. You can see the data. And this is how you can actually verify. That's the blockchain element on top of just the user interface. And that's essentially it. I think there are lots of things you can do around that. The whole point was just playing around with a few API requests. You can see that that data is already stored on the blockchain. You can start proving if that information has been modified or not. And it's just a few minutes. So imagine if you sit down, spend a couple of hours, and try to build an interesting application. You can do very powerful stuff without reinventing the wheel. And the very interesting thing is that this gateway Hermes is open source, so we encourage and we do want people to run those Hermes nodes. We want them to expand and start creating various applications specific for one industry or another, and use the SDK, build a lot of interactive apps. And these are just some of the examples we've done. So now I'll start drinking my beer because I've been speaking enough. What I will do is just before, well, I can, who wants a last technical slide to understand how that works? Or, because there's gonna be a lot of technical stuff coming after, so you can decide. Anyway, so I'll just show you this last slide and then jump in with the next. So essentially what you've seen, everything which I've been showing, what that works is we have one of those Hermes nodes. What happens is I was using the REST API to read and write the data, as you've just seen. What it's doing is this API can store private data in a local database or in an external private database. All of that is in a private network. So imagine this company, if you know them and they want to work with us, you can put them in touch. We're very happy. So imagine they run one of those nodes in their private cloud because they don't want everyone to have access to that data. Not a big deal. They just use the API. They create digital identities for every single one of those products. They can create fun, you know, interactive applications for their product, and all of the data that is private, they don't want to share, for example, production data, pricing, anything that's internal, all that data remains in their cloud. It's their right, it's their data, and what happens is every time they write some private data, they will put that information and a hash, as I've shown, into a bundle. That bundle will be stored on several Atlas nodes. So everything from out there is public. Everyone can see that. And when you go in a bundle, you have the hash of every data in the bundle. You have all the information you've shown, minus the private data, if it's private. If it's public, for example, the image, the name, the size, all of that will be stored here. And then the proof of that bundle will be uploaded on the blockchain. This was the last thing. And this is, of course, entirely coordinated, rewarded, and reinforced, and operated via the blockchain through smart contracts. So that was my part. Now I'll invite some of our key technical guys in the team to just share a little bit what they've been working over in the last few months. So we'll begin with Antoni, who is a lead developer in Warsaw, and he will explain how that works, something that lots of people have been asking, which is the challenges and such. So the stage is yours.
Thank you, Vlad. So, welcome. As Vlad already mentioned, I would like to use today's presentation to actually explain a little bit about challenges, something that a lot of people, like persons in the community, asked. So, let's first start by defining what challenges are and what purpose they serve in our system. If you think about AMB-NET, it's basically a decentralized storage solution. So, as always in this kind of systems, we have a couple of questions we need to ask ourselves. How do we actually reward nodes for storing data? Because they are not voluntary, like they are not charities. How do we check if someone who is supposed to store something is actually storing the stuff? And in the end, as we are decentralized, how do we actually make it decentralized? How we spread the data among different persons and different nodes so that it works. So our answer to that question is our challenges. Challenges are a game theory-based game that, like, no matter what the outcome of the game is, for different actors it will have a different outcome, but for the system, it will be what we want to have. So let's maybe introduce our actors. We have the usual suspects. Let's say we have Bob. Bob is an Atlas node. He has some stake in the system. So to become an Atlas node, he had to actually pay or deposit some stake into the system. Now, Bob at some point in time became a shelter of data, what we call a shelter. So he's responsible for actually holding this bundle one. Okay? Now, we have different actors, also other actors. For example, we have Alice. Alice is also an Atlas node. She has some stake in the system because, yeah. And then, in the end, we have Eve. Yeah, so Eve is almost every time an evil person, but not in this case. So normally, what Eve could do if she's interested in bundle one, because she knows that Bob has the bundle one, she would just use the REST API to download it and not bother with any kind of blockchain interactions, because why should she? Most of the time, she will just get it. But sometimes something can happen. For example, Bob can try to hide the bundle one because some data inside it is not very convenient for him, or something else happens. So what Eve will actually do is to announce on the blockchain, yay, Bob doesn't have the bundle one. And she will actually pay a little fee for that. We'll talk about why this fee is necessary in a moment, but basically that's a claim. That's a claim that Bob is misbehaving. Now, now we need someone to actually judge on this claim, and therefore there are two options. One option, someone makes a counterclaim. This counterclaim is simple. Alice says, I have downloaded bundle one from Bob. So implication, I now have bundle one. For doing that, Alice will be rewarded. She will be rewarded with the fee paid previously by Eve. So that will be Alice's reward for actually resolving the challenge and making the counterclaim, and actually verifying if Bob had the data or not. But as we need to actually make Alice to say the truth, now Alice is also responsible for storing this bundle one. So what we actually did is, she said it's there, but she's now also responsible for holding it. So someone can challenge her. So there is a reward, and there is something that counteracts it, meaning the responsibility to shelter this bundle one. Of course, what if Bob is actually wrongdoing and he's actually doing something wrong? After some time, if nobody said Bob has the data because nobody was able to download the data, Eve can say again on the blockchain, nobody said Bob has bundle one. Time passed, so /him. So what will now happen is Eve will get her money back, because of course she paid for it and it was a valid claim, so she will get it back, and she will also get Bob will be punished, so the pig is now not full, sadly, but a little bit of this stake, this punishment, will go actually to Eve, and that will be her reward for actually finding a wrongdoer in the system. And that's basically challenges. Now, we need to look at it in a more broader perspective, and this perspective is incentives for different actors to do what we want them to do. So, first of all, Atlas nodes want to have rewards. Basically, they are in the system because they want to have rewards. So, if they are able to download bundles, they will resolve this challenge and they will get their reward. Now, they will not risk, or they shouldn't risk being slashed, so they will not resolve challenges that they are unable to download the bundle. And they will actually take care that if they shelter something, they have it and it's available. That's the core concept. Otherwise, they can be challenged and they will, the challenge will expire and they will be slashed. And also a very nice side effect of this is, if we had one copy of the data before the challenge, after the challenge we have now 2 copies of the data. So with every challenge, every claim that is not available, we are actually increasing the redundancy of this data in the system. Yeah. So There is one final question I asked in the beginning and I didn't answer yet, and that's not now coming. How do we actually spread the data? How do we make the data belong to different Atlas nodes? So the answer to that is the system doesn't pick an Atlas node. The Atlas node that resolves the challenge picks themselves, so they volunteer. They say they have it. So Alice maybe didn't want to, maybe she was not interested into it, maybe she was not fast enough, but Max, another Atlas node, he said, I have bundle 1 from Bob, and now I will get my reward. And this basically means Bob has no influence on who actually answers the challenge, which basically means it's distributed. So, any questions? No? So I will now pass on to Dani Hodovic, which is our, who is actually our very good DevOps engineer. So Dani.
Thank you. So let's talk about the infrastructure. We talk a lot about the Hermes node, which is a central piece in the Ambrosus system. And if we demystify this or simplify it a little bit, we have a bunch of sensors. They emit data. I think in Vlad's example was beer. Hermes is this part. What? Can be a beer sensor, can be Coca-Cola, can be anything. Hermes is this part. It's essentially a HTTP API and a database. And in the database, we'd store all of the data. And we store a proof on the blockchain. And the reason I'm pointing this out is because in the blockchain space, people talk a lot about scalability. But if you look at this, it's not a blockchain scalability issue. It becomes a web scalability issue. And the reason that's important is because scaling on the web is mostly a solved problem. Unless you're running google.com or amazon.com, most architectures are the same. So we don't have to invent new patterns. And in the past 2 months, we've been re-architecting and preparing for the mainnet, which is launched. And previously, we had a single machine running Hermes, running the Node API, running Mongo. Now, the problem here is if there's a power outage and we lose that machine, we're offline. The second problem is if you have all of Poland, how many people live in Poland? 40, 50 million? 40? If all those people hit that machine, we're offline. So we had to re-architect to fit to two-tier architecture, basically, where we have multiple Hermes machines, load balanced, and a cluster of Mongo behind that. So essentially, we're solving 3 pain points. We have high availability. If all of Poland goes to our site, we don't go offline. We can take the traffic. The second point is we can scale horizontally. So if we have all of Europe going to the site, in this case, we have to power off the machine, upgrade it, and turn it on again. And in that time span, let's say 20, 30 minutes, we're offline. In this case, we just add another machine. Or database part, we power one off, upgrade it, and then turn it on again. Another thing we did is we migrated to AWS. We were hosted on DigitalOcean before this. Initially, it was a problem where we couldn't get more machines. We were creating enough machines that we ran into a limit, and we looked at AWS, and we realized that it solves a lot of other problems for us, where, first of all, there's higher availability. If we run from machines in Frankfurt, if you run on DigitalOcean, you get 1 data center. If you run with AWS, you get 3 by default. So if one of them goes offline, we are still online. Better security defaults. If you run a machine on DigitalOcean, it's publicly accessible. It's on the internet, meaning anyone in this room can access it. If you run it on AWS, it's private by default. And you need to have the security to be as tight as possible when you're running high-value sites. And then thirdly, AWS has a broader offering. They offer us hosted caching, hosted databases, so that we don't have to reinvent, let's say, the basic building blocks of compute. The more we can focus on our business problem, and the more we can outsource to AWS, the better. And then infrastructure is going forward. The mainnet is not public yet, and one of the reasons for that is that we need to do more load and stress testing before we release it. Because if you onboard, let's say Coca-Cola, and they put out 10,000 sensors at once, you'll get a huge traffic spike, and you need to be prepared to handle that. Second thing is node onboarding package, which Antoni, the previous speaker, is working on, where currently it's difficult to get a Hermes node online. And what we want to do is we want to lower the entry barrier where people can run an installer and get that aligned. And I think for the community, that's a very important piece. And then thirdly, official images and packages. There was a post on Reddit a few days back where a guy gave a tutorial on how to set up a Hermes node. And he gave people an official Amazon image where you just launch this and you're online. Now this is great. It was a very good tutorial. And there's very few tutorials that we've put out there. But the problem with this is if third parties are creating stuff the community runs and you don't know what's inside that machine image, it's a high security vulnerability because you don't know if they're going to hijack your stuff. And then lastly, we need more architecture and onboarding documentation. The project is open source, and we have API documentation, but we're lacking, I think, more documentation on how the bigger picture works, so it's simple to understand. Right, and I'll hand it over to my infrastructure colleague, Conor, who flew all the way from the US.
Thank you. All right, everybody still with us? All right. So I want to take a bit of a deeper dive on the Hermes node. So as kind of everybody's been talking about, the Hermes node represents the gateway between sort of the supply chain or telemetry data and the blockchain. So what I've been focused on is when you're ready to actually go to production. So what configurations do we have and how do we scale to basically any workload? So if we look at this is a basic deployment of the Hermes node. So it's traditional stack. We've got Node.js, which is an application server fronted by Nginx, Mongo database, parity client. So what Dani's working on, so basically to get on board, it's a single script. You're up and running on a single VPS. The benefit of this, easy backups, limited network configuration, low barrier to entry, and basically you're up in minutes. So what do we do when we want to actually start scaling? Developers in the room will notice that this is much more of a productionized topology. So as soon as we want to start breaking out to additional nodes, we can introduce a load balancer. We can start spreading the workload across multiple apps. And as Dani showed, so what we want to do is we deploy a cluster. So the advantage of a cluster is basically we're trying to spread the load of the database. So we have a primary which all the writes flow to. We can deploy secondaries, which that can take some of the load off of the cluster because we can actually spread the reads across the entire cluster. The way this works is basically when we deploy a cluster, it creates a quorum of voting members who all start communicating with each other via heartbeats. If the primary disappears, the two secondaries communicate with each other, form an election, and they vote a primary app. The nice part is the apps actually, the connecting clients know of all the members of the quorum and can immediately switch to that new secondary. So this gives us data durability, high availability, and automatic failover. So this is great. So what do we do when we need even more throughput? Because the one area is we're completely horizontally scalable except for this guy. So now we need to go to the next level. So we introduce sharding. So sharding is basically partitioning our data across multiple servers and instances. So it's a bit more of an advanced configuration, but basically what we have here is, again, load balanced API. We're introducing what are called query routers. The query routers actually read information about the cluster and send the queries to the appropriate shard. So right here we have a config server, so they basically have all the metadata that describe the cluster. So we have a load balancer in front of those, so the actual queries come through the load balancer to the next query set. They communicate with the config servers who then tell them where that data is. So that data goes out into the shards. As you'll see, the actual shards themselves are replica sets. So each one of these basically form a quorum. If one of those members go down, they'll elect a new primary. So this basically allows us to scale almost infinitely. We have no bottlenecks, no issues that we have with a regular replica set. The other interesting part that we can do is we can actually, the members of the replica sets don't actually have to be in the same data center. We can actually deploy the primaries of the replica set in one availability zone and put the backups in another. So if we lose an entire region or a data center, so AWS, Asia Pacific goes down, the system will automatically switch to the next data center, the next availability zone. So this allows us to get extreme durability in the system. The other thing that you can do, which is not on the slide, is you can actually, so the replica sets can be in separate data centers. You can actually have geo-aware queries. So if these shards can actually be put into location zones, so queries coming in can actually be tagged that the metadata will tell it that the query that is needed is in this shard, and that shard is in the US. So if somebody's sending data of an asset in the US, it'll actually land on a shard in the US, which is really cool. So that's something we've been kind of working on and exploring. All of this stuff is going to be codified. You can deploy it with scripts and get up and running. Obviously, this is a little bit more of an advanced configuration, but once you've set up all the servers, IP addresses, everything, you should be able to run single script and get up and running. So that's all I had. Thank you.
Okay. So now what we're going to have in the next stage is we'll take questions. So we'll have a panel with all the previous speakers. And where's Marek? Okay. So we're also going to have our lead blockchain developer, Marek Kirejczyk, joining us. So we're all going to hopefully fit on these chairs. We need one more chair or not? No, only. Yes. So what we'll do is we will start with questions specifically on the technical aspects and so on from the audience. And then we will also have a panel discussion on the blockchain topics and scalability that were asked by the community members. So let's just start with questions from the audience. So any questions on any part of the presentation?
Don't be scared, don't be shy.
If not, we can just start with, oh, is there somebody? Okay. So I'll just start with one of the questions that the community has supplied. So let me just try and move it here. So one of the first questions was, yes? Okay, good. Thanks. Thank you. So one of the questions was that basically the servers, the sensors are tamper-proof, and the implementation is unique because the sensors are connected directly to the blockchain. But what about the API itself? So is it centralized or not? And how are we going to make sure that the data environment and API specifically can fit the overall decentralization philosophy? So I don't know who is the best person to.
I can take that one as it's general. I guess the key question was why if we have those sensors, then they do all the signing on board. Why do we still need some centralization in there? And I think if the only thing we're interested in is taking some data here and there and record it on the blockchain, we can do that. But I think if you look at IoT scenarios where you are actually sending a lot more data than here and there, you have a lot of data to store. And blockchain is obviously not the ideal place to store huge amounts of data. So the first reason why we have those Hermes nodes and everything the guys explained just before is that how do we combine in one single solution huge amounts of data with the proof of that data, and also allow devices that are secure to leverage. So at the end of the day, yes, the data is secure because the sensor are signing it, and no matter if there is a man in the middle, at worst they can delete some data, but they cannot falsify the sensor readings. And that is one part. And the second is all that data that is being sent can be stored on some servers for posteriority if you want to prove any piece of data, and you still have a proof of around all that data. So I don't know if I'm answering the question, but I guess.
If I may add a little bit on top of that, so on technical level, every single let's call it measurement is designed on the device. So by definition, the measurement cannot be falsified along the way. And once it's put on the blockchain, once the metadata, once the hash of the transaction is put on the blockchain, it cannot be deleted, or it cannot be falsified, or it cannot be altered. So we have a very strong model in which once the data is there, it's really hard to get rid of the data. So I think that because you said it can be deleted, the data cannot be deleted. It can be at most being stopped to being right on the blockchain somewhere along the way between the device and the blockchain. Just want to clarify that.
Thanks. Another question that the community has asked is pertaining to the block explorer. So when can, is it also, yes, the second connect? Yeah. Okay, then I'll pass the mic. So basically about the block explorer, so when is the estimated time of arrival, what functionality will it have, and in the block explorer specifically, so what additional features, if any, will there be, and how can people basically track different transactions on it?
Yeah, actually, the block explorer is currently, let's say, being defined. Of course, it will have the features that you would explain from a block explorer, so information about transactions, blocks being mined, who did that, what, and so on. But we are actually thinking about extending that with some information about what was actually the contents of the blocks. Very Ambrosus specific data about, so basically links, for example, to bundles. There is an idea to actually integrate the checker that Vlad presented today. We need to actually look how much of the different tools we want to integrate into the single tool, and how much of this we want to keep outside. Yeah.
So, again, just to clarify a little bit. So the blockchain explorer is up and running, and anyone can go and see how it works. It works on the testnet today. You can see all the transactions, details, and so on. And what we would like to extend it with in the future is ability to browse specific data, like being able to see exact how the measurement looks like, who done the measurement, how the road, and so on and so forth. Yep.
So one question popped up on the video following the slide which mentioned AWS. So one community member is asking if AWS is the recommended solution to use, or should it be used with other providers or any other solutions. So concerning people who want to run nodes, what should they choose basically?
I'd say that the underlying software, we're using Docker for packaging, so it should be generic in terms of deployment. But we will provide guidelines for deploying it on the major cloud providers. Including AWS, obviously, which is the biggest one. Yeah.
So the next question we have is as follows. So one person writes, I'm not clear about the load balancing on the Hermes nodes. Is there an incentive to holding a Hermes node to use for load balancing without using it for creating bundles as well? And does a Hermes holder need to do anything anything special for their node to be used for load balancing, or does it happen on its own?
Just one thing I wanna emphasize: the whole purpose of Hermes nodes is that they provide an API to easily create assets and events, and then they package all those documents into bundles and put them on the blockchain. So just the load balancing part on its own, you cannot really take that away, or just the storing. It's just one piece of software that has a very specific role, and the purpose is create bundles on AMB-NET and write some data.
Yes, but I think load balancing is very important if you consider the second function of a Hermes node being basically a way to query our system and AMB-NET. And as it's something that you query, it's of course needs to be load balanced, because yeah, that's the way you scale servers so that they can handle a huge load. So I think yes, that's the idea about load balancing Hermes nodes. Maybe.
As a simple answer is, if you're running a Hermes node that is not receiving that much traffic, there's no reason to load balance. But if you come on as a big enterprise and you have lots and lots of sensors that are emitting data, then it'll be highly recommended to have, let's say, a more complex and scalable setup. But initially, if you're running something small, it doesn't make a lot of sense.
Yeah, I mean, the only thing I'd add is, yes, the difference between vertical scalability. I mean, eventually AWS doesn't provide you with enough CPU, memory, and storage, so that's when you need to break it out. So it's a balance between complexity and scalability. The other aspect of it is data durability. When you go to that replica set, which obviously is more resources, then you get into having hot standbys, automatic failover. But again, it's a balance between simplicity and complexity. So it's sort of wherever your needs lie.
Just the last bit on the Hermes node, why it's interesting for community or everyone out there is that you can take the source code, which is on our GitHub today, you can run that. Once you understand the gist of it, and you start adapting that and start building apps on top which are more specific for an industry. So for example, you're an expert in, I don't know, fly fishing, and you supply all the fishes fly fished in a specific country. Weird example, you can actually build a fly fishing platform on top of AMB-NET, and then you can resell a fly fishing platform that is powered by AMB-NET at a much higher price that you actually pay for the bundles. And I think this is the most interesting opportunity. We mention a lot, hey, yeah, blockchain allows you to build apps and monetize them. Great. Okay, what does monetize mean? The Hermes node is a very good example of monetization. You take the code, you run it, you customize it for a specific industry or clients, then you can resell that for much higher price than you're actually paying the bundles. And the person you're selling those services to, they would be very happy because they have a fly fishing platform. It's great. They can track their fish that was, fished. So that's a great example. And I think you can apply that to many other industries. So it's really for developers and industries that are going to take a lot of data, build a higher level service and monetize it. So, and once you get to a place where your service is popular, then the whole load balancing will become extremely important.
So there were a few questions about the crypto economics and master nodes. So I guess the general sense over there is just a basic timeline. So for when the onboarding for the master nodes is going to start, and if we discovered anything new or interesting when we ran the simulations and numbers for the rewards on Atlas nodes, Apollo nodes. So how is it influencing our current development of crypto economics, and what is the estimated timeline for onboarding and getting the questionnaires and all the other processes for the community?
Maybe I'll get that one because we're all very sweaty exactly because of these questions. So I think we spent a lot of time in the last 2-3 weeks. It's like we almost live together now after all the time we're spending for the last 2-3 weeks. But the point is, we spent a lot of time rethinking about the details of the crypto economics, because we got some feedback from the community which was really valuable, very important, like, hey, did you think about that? We actually didn't just ignore and say, hey, thanks for the feedback. We actually took a lot of that information, really rethought, and we modified quite a few things, which at least we all, at least me, we are pretty happy about. I'm very happy personally. I think we did a lot of progress from the models that's out there to get something a lot more meaningful. Now we're just testing those newer assumptions, those new ways of doing. I think the new model is a lot fairer because there are lots of worries about, hey, but if you have a faster node than mine, I'm gonna get, I'm not gonna get an opportunity. So we factored that, and we came up with something a lot more interesting, a lot more adapted to the different types of nodes. So I think that's a great achievement. Of course, that changes a little bit what we're building, all the smart contracts, everything we've been building in the last few months. Those changes are not fundamental to an extent, but they will require some rethinking, some remodeling, which is what we're actively doing in the last few weeks. Now, concerning the timeline, I think we're still aiming to get the public onboarding for the mainnet end of October, roughly. That's when we're aiming to start getting everyone the ability to onboard. As we have communicated in the past, at the end of the month, we will start with a softer, more private launch of the main, not launch, but private onboarding of new nodes, community nodes from this. The announcement around that is on the 3rd of September, we will be sending out a newsletter, and that newsletter will contain the link where you can actually subscribe for your node. Regardless if you want to run a Hermes, if you want to run 3 Atlas, whatever you want to do, stay on the watch out. As soon as the newsletter comes out, we invite you to apply through this form, and then gradually over the next 2-3 months, we'll start contacting people who have applied and give them the opportunity to start running a node. Of course, the mainnet will be slower how we take the nodes on board, but we definitely are looking for people who run the testnet nodes as well. That allows us to test, and if you run a testnet, that would give you an additional priority, I would say, in getting a mainnet node. So I think we will communicate a lot more in next 2-3 weeks around that. So stay on the lookout, and that's when it's going to get a lot more real. I mean, it's already pretty real, but it's even more.
So before I take further questions from the community, there are quite a few more. So in the meantime, anybody from the public has any questions? But yes?
Just would like to find out how sensitive the sensors are. I mean, what's the range of temperature they work well at?
Yeah, so I'll give the brief answer here myself. So the sensors can be anything. So we don't manufacture sensors ourselves. We work with external providers. So we build the protocols to link the sensory data to the platform, but the sensitivity of the sensors, the calibrations, all the hardware part, that remains on the side of the manufacturers. So from that perspective, from our side, it can be anything. It can be very sensitive, so it can go down to multiple decimal places, or it can be plus minus half a degree. We don't, the platform doesn't care. Any other questions? Yes?
I think just to reply on that, as Angel said, the platform itself, especially if you send data through the REST API and you're signing, it doesn't matter. It all comes down to you as a company. If you're buying sensor from A, B, or C as a sensor manufacturer, you have to trust the hardware of that company to an extent. Yeah, we can. I mean, we are doing R&D very actively, and that's what Angel mentioned. We have our lab in Yverdon where we're actively looking at new sensor technologies. We're connecting, we're testing, we're permanently improving, and we do have our own sensors in house, but they're more used as a prototyping platform at the moment. We don't plan currently to mass manufacture sensor and say, hey, that is the official one and you have to buy it here. We have those sensors, we're using them for client projects, and that's still to be defined. If we see there's a lot of value to create those ultra secure sensors and people want that, then it's going to be interesting, but it will depend on your use case. Every use case will require, if you do cold chain monitoring in Alaska, or if you do, I don't know, tropical fish in Southeast Asia where humidity is 80 degrees, 80%, you need a very different type of hardware. So, but yeah, I think it's a very good question. Did I reply? Yeah. I mean, the point is, if you need -60, then of course your sensor will be a lot more expensive. So, and I think this is really down to what you're measuring. If you're measuring a box of shrimps that are industrially farmed, that's not the same thing if you're measuring like very expensive luxury wine shipped from a company. Good. Any other?
Hi. The question from the legal side, let's say. You have on your presentation example of food industry, for example. Food industry is quite regulated. The same would be with healthcare industry. If we put sensors in this area, any business should be especially scrutinized and audited and demonstrated in front of regulators that every layers in the concept has certain quality, and the quality is somehow measured. What is your approach to the compliance in that sense? What did you already applied? What is in front of you? How you see this challenge?
Yes, so I can take that question since it's above all kind of a business and regulatory question. So you're quite right. I would say the basic difference between the food industry and the pharma industry is that the pharma industry is even more regulated than the food one. And we are currently running multiple pilot projects and use cases with large corporates, as well as with certification agencies and public sector stakeholders, to specifically test out AMB-NET in industrial environments, to specifically see how this data integrity can be conformed, because a lot of new regulations that are coming in both in the food and in the pharma, especially in the pharma sector, is all about data integrity, linked to traceability, linked to quality of storage and so on. But basically everybody's searching for a perfect platform to assure the quality of products. Now, it's been well established that blockchain as a technology is a highly suitable solution for that. But then, of course, we go into the nitty-gritty of how do you, above all, connect the sensors that would inform about the quality of the product. And this is specifically the part that we decided to focus on, providing this linkage between real-world data and the distributed ledger technologies, so all the data that goes there. So this is exactly the point why we've been running different tests. It does take time, so I agree with you that it's first you validate your idea with corporate stakeholders, then you try and present it to the governmental bodies, and Ambrosus has been working with the public sector stakeholders. So we're an official partner to the United Nations 10YFP, Sustainable Food Systems Program. We have been endorsed, and actually we've recently been selected as the Rising Food Stars by EIT, that's the European Institute of Technology, so that's the government of the European Union. And we've been working with a few quality assurance agencies, kind of the governmental bodies in different countries, to specifically see how their certification processes could be basically could be executed on AMB-NET. So this is exactly our goal, to provide the solutions and tools for those stakeholders to be able to make use of our blockchain.
Just to add one point to that, a lot of our technology is open source, and we intend to keep it that way, and we intend to have, as more of our technology matures, we intend to make ultimately everything open source. Why? Because people can go and check what's in there, what we're building. It's not a SaaS model where, oh, it's a black box and there's a monthly fee and you don't know what's inside. It's the opposite. It's like, hey, you can run it. It costs just your tech name. We can of course run it for you if that's important. But what's really essential, and especially the JSON checker thing which I showed before, this is open source, and it's really important that anyone who says, oh, this data, I don't trust it, okay, I'm gonna check myself. Most consumers, they won't be running KCAC 256 hashes themselves, but they can. The point is, like, if there's a person who doesn't trust some data, they can check, and if a company is sending if it's putting wrong data, they will automatically be spotted on. I mean, you can't go wrong with this technology, as soon as you start to put a false statement, everyone can see if you're full of shit or not. Sorry for the word, but I think that's really what it comes down to. And I think it's at the end of the day, and that touches the question around centralization, which is interesting, is that when you go on a website and you have the little green lock in your browser, you're not going to check if the certificate is actually valid and signed. You kind of take it for granted. Just like when you go on Etherscan, there's a transaction, you're like, I don't trust this website. Well, it's a website that provides you data. I think 99.9% of blockchain enthusiasts, or they go on Etherscan and it's centralized and they're happy with it. Of course, if they don't believe, they can check it. And I think that's the same approach around compliance. Companies can be a lot more transparent. What organic means, let me show you what organic for me means. It's this, that, and this test. Here are the results. Do you believe it or not? And you can trust that the data I'm sharing is not fabricated. And I think that's the power of blockchain.
Any further questions from the audience? Yes?
So, hello. And last year you partnered with the Trek Therapeutics, and my question is, can we see any results of those partnerships?
Yes, so I'll briefly mention, so we haven't spoken with them obviously about commenting in public about the partnership itself. The point of the partnership was to test drive our solution and to see how it specifically applies in the industry of healthcare. So more generally speaking, with other similar companies with whom we've worked, we've developed the specific use cases for AMB-NET in the pharmaceutical sector. We've developed new dApps that we're now using to approach other companies. So such partnerships, at the very least, they provide us with kind of business case development, and they also provide us with opportunities to see what problems the pharmaceutical sector is facing and what solutions on the IoT or blockchain we can solve for them. Any further questions? So I'll give one more from the community. It's 3 related questions, so I'll try and jump them together. So the first question is pretty specific. So somebody asked, will it be possible to pause our node in order to make some maintenance or changes to the VPS? Related to that is there anybody on Ambrosus team who might be supporting people with such queries or any other kind of rollout of the network stages? Yeah, basically tech support, but specifically in the context of rolling out the network and maintaining the nodes. And then finally, if we plan to have any preferred IT vendors or partners to help either individuals or organizations to onboard and launch their nodes.
Yeah, so answering the first question, we don't really say that it should be possible to pause your Atlas node or Hermes node, but the thing that I talked about, expiration of a challenge, it doesn't happen very quickly. It's days. So if you need to take your node down for a couple of hours, I think it should be fine. There should be no repercussions, no slashing for you. Of course, it shouldn't take more than a couple of days, of course.
I would say the preferred way to upgrade or update a node would be to set up a new instance, test it, then switch the instances and have the 0 downtime. That being said, there is a limited period of time measured in hours where if something goes down, there is no penalty.
Can I also know the last one? We try to do everything in our possibility to make setuping a node very easy. Of course, this basic setup will not be as say advanced what maybe Conor and Dani presented, because that were more setups for corporates. But the basic thing, if it's not super, if it doesn't need to handle huge scales, this should be doable by a normal person, and we will actually provide some small software package that will help out with that. About partnerships, I think I will give to Vlad.
Yeah, just for the second question, which was, are we going to provide some support? So I think, especially from November onwards, once we'll have the public onboarding, then just as Antoni mentioned, we'll do a big effort in next few months to provide all the tooling necessary to make as easy, as risk-free as possible to operate your node. You still need to be aware that you're actually storing data of a company, and that company has paid you to store that data. So, you know, just like if you go to Amazon and you're paying them to store your data and they're like, oh yeah, we're down for like a day or two, you're not gonna be happy. So the short answer is we need to make sure this happens to the limited amount of in time. We will be exploring how we can make that possible, because we've got that request, of course. And to help you on board, we'll do our best to make sure that technically you can run the stuff and you almost don't need to contact us, or you don't need to support. That's our objective. If that will happen, we'll see. I hope we will. But in any case, we especially that's one of the key objectives from my side as well, is to set up a lot more the developer program over the next 2-3 months, because our product is reaching finally maturity when it can start being used, when we want to increase the number of developers. So providing a lot more support, a lot more documentation, a lot more, you know, I wouldn't say 24/7 for the community, but we will explore ways, just like on Telegram we have community managers. I would be really, really excited and looking forward, if anyone is interested and starts to play around with our tech, there will be opportunities to participate in that sense. How much of the team we'll see, but we want to help. And in general, some people who have asked us that questions, we've been helping, so it's really valuable for us to get developer feedback. On the partnership, I mean, I think we'll see. I think if we do specific partnerships with one cloud provider or another, there were some comments that, oh, but it leads to centralization because you're kind of incentivizing people to use this cloud provider over the other. We can try to be neutral and find out several providers that are willing to participate, so we don't prioritize one over the other in terms of decentralization, but I think this will be defined later. I don't know if you want to add something
On the cloud provider part, I'd say we need to make it simplified, make it generic, so that you can have 5 or 6 cloud providers and there's a set of instructions for people to set up a node. So essentially simplifying it and lowering the entry barrier. And on the second question for tech support, I think the way to go there initially is to provide as much documentation and best practices as possible, because it's still a small team. I mean, Amazon has thousands of people in tech support and it's still problematic. So tech support doesn't scale because you need to hire more and more people the more consumers you have, right? Anything you want to?
I mean, the one thing I'd add just about the pausing of the node, especially with the Hermes node and Atlas, I mean, I think we can come up with guides, operational guides, where there should really be no reason, especially for upgrading, to ever pause the node. I mean, to Marek's point, if you're running a sort of omnibus, everything built into one, and you need to upgrade the node, and there's going to be some downtime, you take a snapshot, you deploy it. There's a way to bring it up and actually replicate the data temporarily from the one to the other, switch the DNS, and then you can take the other one down. So, I mean, there's steps that are pretty easy to follow that we can do. Obviously, if you scale and you have that replica set, what you do is you upgrade the primary, another one will be elected, and then basically you just upgrade one at a time. So I think a lot of this stuff we can build operational guides where we can kind of walk people through the best way to do it based on their configuration.
I guess since the pizza has now arrived, I'm just going to give one last general question, and then people can proceed to having a good evening and dinner. So just on scalability, so what is, in each of your opinions, what is the most promising solution amongst the many proposed for scaling of blockchain solutions? And maybe you can give a bit of insights on what you believe they can be and so on.
The scalability topic is very hot, and truth to be told, there's a lot of ideas and a lot of experimentation, but we don't yet see the clear path. There is there's sharding, there is distributed file system, there are plasma chains, So a bunch of different ideas, and a lot of them have working testing networks, but it doesn't necessarily mean they are just around the corner. With Ambrosus, we were able to achieve scalability because we say, okay, how many times do we need to store every single information for it to be very secure? Well, on blockchain, what happens is every single transaction is stored on every single node. That's very big redundancy. For our data, we say if we store it and it's redundant by a factor of 5 or by the factor of 10, well, I would say for specific data of the vendors, that's already very high redundancy, and that's perfectly enough. So the way we achieve scalability is we still have a blockchain which have very high redundancy with every single node storing all the metadata of Ambrosus, but we have limited redundancy, or well, it's still very high redundancy. If you go to any server setup like Google or Facebook, they have 3 copies of all the data, right? We have, I don't know, I think the setup is currently 7 copies, is that correct? We have 7 copies, so we're more than double than that. And because we were able to loosen this one restriction, because we say, okay, we don't need that high security, that high redundancy on this particular type of the data, we were able to design and build something that kind of works today, and we're rolling out a production any month now, without the need to wait for all those research on all those topics to kind of conclude. So that's, I think, biggest overview on scalability of blockchain in general, and also Ambrosus.
I think if, like, to add a little bit on what Marek said, I think if you look at, for example, Ambrosus use case, I don't think any of the proposed solutions for scalability will ever manage to handle our loads. Basically because our loads are like very, very big. And there are a lot of use cases that are similar, and there will never be a scalability solution that will manage to scale up to this point. So I personally believe very strongly into a set of technologies that you call off-chain, where you do stuff off-chain using signatures, using strong cryptography, and then you just notarize and you like provide a process on the blockchain, which is very strict and provides the ultimate way of solving problems, only for like escalation or like what we do, for example, for challenges, and that's a game changer, an enabler. That's basically the same thing that state channels do. Like a bulk of the data is actually transited off-chain, and then at some point we only store the very important bits of it, like the beginning, the end, or any kind of escalation in between. And that's the power of blockchain and off-chain together.
For me, I mean, scalability has become the buzzword of the year in blockchain, and the thing is, it's a portmanteau. Like, use this word for anything. I mean, we need to define what does exactly scalability mean in your use case. Are we talking number of transactions per second? Because that's what it means for a person. For another one, are we talking the number of requests or the time it takes for my transfer of one number to Angel? Is that scalability? How fast, when, or how many users can use the system at the same time? How much data can we store in terabytes, petabytes? There are so many different definitions of scalability that it's very hard to put them all under one technology. And I think from what my colleague said just before is that at the end of the day, we've tried to be very, very pragmatic here. And we said, look, blockchain has a lot of very cool advantages, and we want to leverage them. We want to max out those things that we cannot do easily in a more centralized way. But when you look at things such as sidechains, essentially what you're doing is you're training a little bit the fact that, oh, it's fully decentralized and checked by a bunch of computers by having less witnesses in the room in order to do a lot more data transfer. And it's like when you have a meeting, if you have 30 people in the room, you'll never agree a design decision. So sometimes it's better just to take Antoni on the side, do some drawings on a blackboard, and then we have a solution. It's a lot faster, and that's scalability in a certain way. So I think we've been very pragmatic in our sense, to try to get very strongly inspired and look at the needs from an IoT solution in general. When you look at IoT clouds, it's one big SaaS that is, they're trying very, very hard to scale to the thousands of events and megabytes per second using sharding, and it's very, very difficult. It's just one server. What we try to do is to say, hold on, first, you don't need to have one massive server that holds all the data in the universe. You can have a bunch of smaller servers that you don't need to scale that extremely, because at the end of the day, there's no point for all the data in the universe to be in one single place. You can distribute that. That's I think one of the most important consideration from my perspective is, at the end of the day, do you need to put every single sensor reading? Like here is a smoke detector, it's checking maybe every 30 seconds. Who needs the 5 years time history of no, there was nothing, no, there was nothing? I mean, are you going to store megabytes of this guy saying that no, there is smoke somewhere? Are you going to pay for that? At the end of the day, the only thing you need to store is like, hey, there was a fire last week, or there was some smoke detected. That's the only information you need to store. Everything else can be decentralized as long as you can be centralized as long as you can prove it's been done right.
I concur with Antoni. If you can store the proof or a fraction of the data on the blockchain and the rest in a database, I think it solves most of the problem, I think in our use case at least. The web has existed with public usage for 20, 25 years, whereas blockchain is a very, let's say, relatively new concept.
I think everybody's hungry, wants to eat some pizza. I mean, I think I agree with the panel that I think there's a place for traditional software to basically amplify the blockchain. I don't think you're ever going to get the blockchain to meet or exceed a traditional stack, and there's a place for both. And that's, you know, I think that's the beauty of the bundle, is basically collating all this data, signing it, and then just placing the proof on the blockchain. So. Yeah, I think that's where the solutions for scaling lie, is basically a hybrid of a lot of different things. So
it's a sign of peace, where it's not decentralized versus centralized, which doesn't make any sense. It's like, okay, let's take what works in one world, what works best in the other, and find the best way to make them work together, because we can't wait 5 years until, hey, we found scalability solution on the blockchain. We have to be pragmatic, and that's what we're trying to do.
Okay, thank you very much. Thank you very much for everybody who's come here today, and thank you everybody who's been following us through the live stream. Our team will be in more cities in the next few weeks, so if you have any proposals or suggestions, or you want to invite us to any particular place, just drop us a line on the social media or on Telegram, Reddit, or elsewhere, and we will be happy to, you know, next time we're in a particular country or city, to host another meetup. So thank you very much, and enjoy your pizza. Thanks.